Hello. So my project is over maximization of profit on our gas products. Our gas products use nitrogen, hydrogen, and chlorine. We do have a limited amount of resources on all of these. We're going to be selling it to two customers. One of these customers, if you do not sell a certain product for, they will not buy it. So here we have is our chart explaining detailing of our products. We have our custom gas and our chloride. And customer one wants to buy custom gas and chloride, so they get their own little section for that. Then we have customer two who will buy chloride, custom gas, and oxygen. So we have that going on. And each of these special gases requires a blend of nitrogen, hydrogen, or chloride, with the exception of oxygen, which isn't really a blend, but you do require to make nitrogen to get oxygen in our setup. This does also require a setup cost of $500. And then here we have our supply of nitrogen, hydrogen, and chlorine. Alright, here's my original linear algebra problem that I deduced from the original source code. They started off with only one customer and only two products, and we wanted to expand the company. So here's my modified linear algebra problem. Here you can see that we have a check installed to see if customer 2 is going to buy anything, which is only going to happen if he buys oxygen. If not, we're only going to have customer 1, which you see on the left. And then here's your setup cost. And then here's the rest of the check to make sure that this is a binary K. Alright, and I went ahead and made a almost a network diagram. This isn't a network problem, this is a blending problem, but for visual representation, it was easier to create some sort of flow chart to understand and to apply what we learned previously. Here we have our supply, which is always in the negative, and then our customers who don't have a limit on how much they will buy. But then we do have this special if-then decision right here. And I denoted the path of the oxygen in a white arrow for ease of understanding. So if they buy oxygen, they can buy chloride. But if they buy oxygen, they don't have to. So here we see that flow. And here we see the code. At first I tried to do an if-then statement. I found that it would be a more proper way to solve this, but I was struggling pretty bad with the syntax of the specific language. And I did try to find some resources, but I decided that a more mathematical way would be better instead of a standard programming way, if that makes sense. Here we have the working code. So instead of doing an if-then, I added a new variable, which was your test, which if you went back to the linear algebra, would be that K value. I did set it to a binary. I did declare it as an integer, so it has to be a positive whole number. And then I also set it has to be equal to or less than 1, so it only leaves 1 or 0. So if you did try to input something else here, it wouldn't work, which is what we want it to do, is to not work if you don't put the correct values in. And then this is our solution. Interestingly enough, even with the setup cost, we still chose to produce oxygen. And then after working this out, I figured that none of the chloride or the chloride or the oxygen used hydrogen, I believe. yeah. That's why we only have two productions for production 2, because he wasn't going to buy it anyways. And that is what I did for my project. Thank you. Let's see, get out of here.